everyone, welcome to Day 5 challenge. Today we're going to tackle the hardest question, number 7. The answers are E, D, and D. Now let's look at the first one. For how many not necessarily positive integer values of n is the value of 4000 times 2/5 and raise it to the nth power an integer? Alright, so first of all, we notice that if n is a positive number, and then you just need to find out how many 5s can we factor out from the number 4000. And instead, if n is a negative number, 2 will be the new denominator, and you're gonna looking for how many 2s do we have. Alright, so first of all, we need to do the prime factorization for the number 4000. Let's do it. So 4000 can be broken down into 4 and 1000, and as for 4, it's equivalent to 2 squared, and as for 1000, that is 2 cubed times 5 cubed. So it's equal to 2 to the 5th times 5 to the 3rd. Alright, so if n is a positive number, you can see we need to look at the exponent on 5, so 5 to the 3rd. So that means the largest possible value for n is 3. So as for positive numbers, we have 1, 2, 3. And let's look at some non-negative numbers. And 0, if n is 0, it works. And what about the least possible number? So this time we're going to focus on the exponent on 2. So 2 to the 5th means the least possible number for n could be -5. Alright, so now I just know n can be any number between -5 and 3. So in total we have 9 options. So we choose option E. Alright, let's go to the second part. In the figure below, incongruent semicircles are drawn along the diameter of the large semicircle, with their diameters covering the diameter of the large semicircle with no overlap. Let A be the combined area of small semicircles, and B be the area of the region inside the large semicircles, but outside the small semicircles. The ratio of A to B is 1 to 18, so what is n? Okay, so if we already know what is the ratio of A to B, equivalent to say we can easily find out the ratio of the sum of all small semicircles to the large semicircle, right? Okay, now let me write it down. So the sum of the area of small semicircles would be the capital N times the area of the small semicircles. And as for the big semicircle, let me just put it here. The area of big semicircle, it's equal to 1 over 19, right? Alright, and now let's just assume as for the small semicircle, the radius is r, so we do n times pi r squared. And as for the large semicircle, also pi times the radius squared. So this time the radius is n times r, so pi times n r squared. And that's equal to 1 over 19. After simplifying the fraction on the left hand side, you're going to get 1 over n is equal to 1 over 19, which indicates the capital N is 19. So we choose option D. Okay, so the last one. In a plan, 4 circles with radii 1, 3, 5, and 7 are all tangent to the line at the same point A, but they may be on either side of L. Region S consists of all the points that lie inside exactly one of the 4 circles. So what is the maximum possible area of region S? Alright, so first of all, let me draw this tangent line L, and in order to maximize the area of region S, so I will firstly put the 2 largest circles on 2 sides of L, like this. And right now, I just know the sum of the area will just be region S, right? So let me do 25 pi plus 49 pi. Okay, and now I have to put another 2 circles, since all of the circles are tangent to L at point A. So the 2 small circles would be inside the large circles. So I just realized I can put let me put the second smallest circle right over here. So it doesn't matter if I put it above L or below L. I should always subtract the area of this circle. So that is 9 pi. And now I have like the last circle, the smallest one. And now I'm thinking of if I put it on the same side with the circle with radius 3, then I don't have to subtract. I don't have to subtract another pi. But if I put it below L, I have to subtract another pi. And since we want the maximum possible area, so that the smallest circle must be on the same side with the second smallest circle. Okay, so the area, the maximum possible area of region S would be 25 plus 49 minus 9, that is 65. So 65 pi, which is option D. Alright, that's all for today. See you next time.